Greetings, now you know about for loops. Let's look at if statements. So I want to give you an example that comes from some of my students' code from last year. They were making a game, and in the game you had a score that accumulates as you get more points. And at certain threshold values, like when your score is above 10 or when your score is above 20, he wanted to increase the level that you were at. And if you were at a higher level, the enemies would come faster, there would be more enemies, and so on. So the problem that he needed to solve was, for a particular score, he needed to calculate what level should the game be at. So here I've created a score and a level that are both 0. Why don't you convince yourself what this does? If you recall from before, math.random is a double between 0 and 1. When I multiply it by 100, now it's between 0 and 100, and I've truncated it to an integer. So now it's between 0 and 99. 99 because even though math.random is between 0 and 1, it's never actually equal to 1. So that means when I truncate it, I delete the decimal portion. Okay, so here was the solution he came up with. He said, if the score is greater than or equal to 0, and also the score is smaller than 10, then set the level to be 0. Otherwise, if the score is greater than or equal to 10, and also the score is less than 20, then the level's 1. Otherwise, if the score is greater than or equal to 20, and also the score is less than 30, then the level's 2, and so on. So he has a series of tests to test if the score is inside each possible range of values he's interested in, and depending on whether or not it is, he assigns the correct value for the level number. A couple of things to note here. In math, it would be totally normal to do this for a comparison. In Java, you can't do this because in Java, this is actually two separate comparisons. As I said before, we're asking if score is larger than or equal to 0, and also we're asking if score is less than 10. So that's really asking two questions. So whenever you're asking more than one question, you have to combine them together somehow. This double ampersand is a logical AND operator. I usually pronounce it as and also because I think that captures logically what's happening. It's a way of combining together two Boolean expressions, so these are both expressions that are true or false, into a single larger expression. And logical AND will be true only if both of these expressions are true. So if this one is true and also this one is true, then the whole thing is true. If this one is true, but this one is false, then the whole thing will be false. So if either one of these or both of them are false, overall it will be false. All right, well, let's run it to make sure it works. Okay, so as you can see, I'm running it. Score is 24, level is 2. Score is 79, level is 0. Why is that? Aha. When it was 79, none of these if statements were true, and so when I got to the print statement, level was the same thing I initialized it to be. So in his game, he had if statements that went all the way up to 100. But 17, level 1, so more or less this seems to be working. 3, level 0, 91, level 0, because we don't have an if statement, 29, levels 2. Okay, great. So we're going to solve this same problem in two different ways that are going to be more and more efficient. So here's my first observation. We've got several if statements, but these are always following the same pattern. We're saying if score is between two different numbers, then assign a certain value to level. So instead of repeating this if statement using copy and paste 9 times, let's write a loop. So I is 0, I is less than 10, I plus plus, so this is going to loop 9 times. And then what's the statement I want to repeat 9 times? It's this if statement, something like this. Except what's changing? So from one if statement to the next, score is the same, level's the same, all of these assignments are the same. The only thing that's really changing are these numbers. What's the low number, and what's the high number, and what's this level number. So this is the general pattern we want it to have. Okay, so since I is looping from 0 to 9, it looks like that's the level numbers, because that's a number that goes from 0 to 9. So if I make I the level number that I'm going to assign, now I've got to figure out what's the low and the high score that would correspond to level I. So when level 0, I would want this to be 0 and this to be 10. When level is 1, I would want this to be 10 and this to be 20. So I'm trying to think, what can I do to this number? Let's just use the lower score, for example. So what can I do to 0 to turn it into 0? Well, nothing. Okay, what could I do to 1 to turn it into 10? I could add 9 or multiply by 10. What could I do to 2 to turn it into 20? Adding 9 isn't going to work, but multiplying by 10 still works. What about 3 into 30? Yep, multiplying by 10 works. So it seems like if I say I times 10, now no matter what my level number is, if I multiply it by 10, I'm always getting the low score that I would want to use to test. Okay, what about the high score? It looks like the high score is always 10 larger than the low score, so here I could say I times 10 plus 10. Or you could do I times 11 if you want to do that. So now, if you're thinking about running this in your head, which you should always be doing, or rather you should always pause once you've written a thing and go back and think about what do you expect it to do. The first time through the loop, I is 0, so this is going to be 0, and this is going to be 0 plus 10 is 10. And that fits with what I had before. Okay, the next time through the loop, I is 1, so this is going to be 10. This is going to be 10 plus 10 is 20. So that corresponds to 10 and 20 here. So now as I'm repeating, instead of 10 if statements, I'm looping 10 times, and I'm just looping over a single if statement. So this is a much more efficient way to do it. Not efficient in terms of how fast the code runs, efficient in terms of it's a much shorter number of lines, smaller number of lines. So seems to be working. 73, level 7, 31, levels 3, 53, levels 5. So this looks like it's working great. And this would be a great use of the for loop. There's actually a much more efficient way to calculate this in this case, however. What I'm noticing here in the output is the level number is always exactly what you would get if you just chopped off the last digit here. 27, 2, 51, 5, 82, 8. So I don't actually need to test to see if the numbers in the 80s assign 8, if the numbers in the 70s assign 7. Instead, I can just divide the score by 10 and throw away the decimal answer. So instead of this, a much more direct way to do it would be something like this. Score equals, level equals score divided by 10. Notice score is an integer. This is an integer. So this is going to perform integer division, which means it will divide it by 10, but then it will discard the decimal portion. That's called truncating, so it will truncate the decimal portion. And if I run it again, you'll notice I'm getting the exact same values I was before. So again, this goes to emphasize that there's lots of ways of solving problems usually when you're programming, and it's worth thinking about, because if this appeared in a much larger program, you know, we took something that was almost 30 lines of code. Using the for loop, we reduced it to about 4 lines of code. But really, it was such a simple function, we could do what used to be what we used to do in 30 lines of code in a single line of code.